So this is very exciting. It is time for us to start getting into the strategies and the engine. So the first thing we're going to do is we're going to create a new folder, and we're going to call this strategies. Strategies. Nice. Inside of that, I will have a new item. It's going to be an interface, and I'm going to call it iSudokuStrategy. iSudokuStrategy. Inside of that, I will say int, and then it's going to be solve int Sudoku board. Let's go over this real quick. Not much here, but we have an interface, and that interface says, hey, I'm a contract. Anything that is trying to implement me needs to have a method called solve that it's taking in a two-dimensional array and then giving back a two-dimensional array. So the strategies that we create for our Sudoku solver are going to implement this guy, and this guy is going to be the layer of abstraction, right? Because we're going to say, hey, strategy.solve. We don't know what strategy it is, but there are going to be multiple implementations. They are going to be all implementing the strategy to, have their own ways of solving the puzzle, but we won't know about it. So the end user won't know about it. And you'll see how beautiful it all fits together once we have it all ready. But for now, just know that we have this interface and we're going to use it. Now, we close that, so we don't need the strategy anymore. The next thing we're going to do is go to strategies and create another class. And I'm going to call this one SudokuSolverEngine. SudokuSolverEngine. So SudokuSolverEngine. So now I'm going to create two private read-only. So these are fields, and then I'm going to say Sudoku board state manager. Sudoku board state manager. Remember, this is the one that we already created, so we can get that from the workers, and then put that in there. So Sudoku board state manager, we got the first one. Then private read only. We need the other one, which is Sudoku mapper. Sudoku mapper. And this is going to be the Sudoku mapper that we also created. Then going to have a Sudoku solver engine. That is going to take in Sudoku board manager and a Sudoku mapper. So let's see right here. We're basically doing dependency injection right here. And we know that we are dependent on Sudoku board manager and Sudoku mapper. That's why we have separate classes that take care of these responsibilities. Remember, we created the responsibilities first, and then when we're trying to put them all together, we use DI to put these responsibilities inside of the like the main class that needs all these helper classes. So we're going to say, okay, well, the Sudoku board state manager is going to be the one that you pass in, and then I'm going to say the same thing is going to happen with the Sudoku mapper. And that's that for now. And our constructor is finished. Next is our method, which we're going to say public bool solve. This is not the same solve that we saw on the interface, by the way. It might be a little bit confusing. This is still not being used. This is kind of like sitting there. We're going to get back to it in a little bit. The solve, it's the same name, but it's a different method. It has nothing to do with the interface. So this solve is also going to take in a two-dimensional array, Sudoku board, I'm going to call it. And the bool is going to be return Sudoku board manager dot is solved. And guess what we're going to pass in? The Sudoku board. That's right. So at the end, so this solve method is going to have all the stuff that, you know, takes all the strategies together, puts them together, runs them, checks the state, if they equal, if they're not. And then after that says, okay, well, you know, when the states don't equal or, you know, it's not solved, whatever the condition is, it gives back whether the Sudoku board has been solved or not. And that's how you get back the, you know, the answer as a Boolean value. Now let's go ahead and create the rest of it. So I will say list. I'm going to create a list, and I'm going to put in iSudoku strategy in that list. And I'm going to call it strategies. So strategies equals new, and an empty list. It won't have anything in it, but I will initialize it like this, just so later on it's easier for us to kind of put stuff in it when we want to. And here it is. So this is where our strategies are going to go. But here's the beautiful part. Check this out. So I will go over the code after I write it. Current state equals Sudoku board manager dot generate state Sudoku board, and then I'm going to say next state equals Sudoku board manager generate state, and I'm going to say strategies first. In this case, we don't have, you know, at first, so this will actually not work. But when we start adding stuff in there, you know, this should, you know, work just fine. So solve the Sudoku puzzle right here. Now what we're going to do is we're going to say while Sudoku board manager is solved, while it's not solved and the current state is not equal to the next state, continue on the loop. Now what do we have in the loop? Well, we're going to say current state is equal to the next state, and then for each, so we need to close this statement, for each var strategy in strategies, so we're going through all the strategies that we have in the list, we're going to say next state equals Sudoku board manager generate state strategy, just single strategy, dot solve, and then the Sudoku board, which is this, and close statement. So that's pretty much it. And at the end, we're going to return whether the Sudoku has been solved or not. So now let's go over this. And we can actually make this a little bit shorter by taking this out the block, because it's only one line. So we can just do that, and that way it's a lot shorter and easier to read as well. But you can keep it on a block if you'd like to. So let's go ahead and go over this code real quickly. So you see that I have these dependencies. That just means that the Sudoku Solver engine needs functionality from the Sudoku board state manager and from Sudoku mapper. Now, the Sudoku mapper is not being used just yet, but that's okay because we're going to use it at one point. So just leave it there. Now, the Sudoku board state manager is used right here when we're saying, okay, initialize all of our strategies, then generate the state for the initial, you know, once we get the board, once we load it from the file, generate the state. That's the current state. Then the next state is going to be when we run the very first strategy, whatever strategy it is. It doesn't really matter which strategy it is. Notice here that we're getting the first element and we're running solve. The solve, since iSudoku strategy is a contract, it says, well, whatever strategy you put in, it has to have a solve on it, and that will take a Sudoku board. Whatever it does with that board, I don't know, but you know, it's gonna do what it's gonna do. I just know that it's gonna take a Sudoku board and it's gonna give back a Sudoku board. So this guy will take a Sudoku board, do whatever it needs to do with it, and notice, even when it says first right now, we don't have anything in it, but it just knows that the list, once it has stuff in it, it knows that it's going to have a iSudoku strategy. Something, you know, a class that implements a iSudoku strategy. That's why it can assume that it must have a solve. So then it says, okay, well, if it has a solve and you pass that in, it's going to give back another Sudoku strategy, right? Board back. Once you solve, it's going to do something with it and give back a Sudoku strategy board. Then you're going to generate the state for that new board, and you're going to get a new state, which is going to be the next state. So then you're going to say, okay, let me now run it through this loop. So you now say, okay, the Sudoku board strategy, is it solved? Because it might be that your first strategy was so strong that it solved the puzzle right away. So you don't even have to run it through the loop. So if this condition has met, meaning that the Sudoku board is solved, then you will exit the loop and say that it is solved right here. But if the Sudoku board is not solved and the current state, which is the initial state, is not equal to the next state, which means that it wasn't solved, but still your strategy did something with it, right? Because the only time the current state will equal to the next state if the strategy didn't have any effect on the Sudoku board. That way, basically our current state and the next state will always be the same. And they're like, okay, well, the strategy was so weak, it didn't do anything. So exit out the loop. And, so these are the cases. If the current state doesn't equal to the next state, meaning that the strategy was strong enough to do something with the board, and if it was strong enough to solve it right away, then even better. But if, these conditions have to be true, there has to be a change, and it hasn't have to be solved. If those two are correct, then we say, okay, well, the current state is going to be the next state now, right? The current state is going to be the next state. Then what we do is we run through all these strategies right here, and we say that the next state is going to be the next state of the strategy that's solving the Sudoku board. So we're going to solve the Sudoku board and generate a new state and pop it into the next state. Go to the next strategy, do the same thing. If we have 60 strategies here, this is basically going to solve it for each and every one of them. And at the end, the 60th strategy is going to generate some state, and then that's going to be the next state. Then when we get back right in here, it's going to check it again. Is the Sudoku board solved? If it is, get out the loop. If the current state equals to the next state, that means none of these strategies had an effect, meaning that the current strategy or the current state equals to the next state still, because the next state has not been changed. So that means that our strategies were weak. But if there was a change, then still go and loop around again and again and again and again. So you see that this loop will run until it's either solved or it realizes that it can't be solved. And then we print out the answer. We say, okay, just give us back whether it was solved or not. And that's what we get back out of this method. And I hope this makes sense. We're going to move forward. And this is kind of one of our key classes. That's why I wanted to spend a little bit more time talking about it. But that's it for now.